So good morning again, and please excuse my voice because I'm not in the best shape in terms of voice this morning, but I'll try to go through the presentation. And let me start with a slide that I always like to show to center the situation that we have currently in Florida right now, as we are planting more and more citrus trees every year. So we have a situation in which we have young and mature trees, and as we all know, they all have different biology and also different requirements. So for instance, young trees are planted healthy and they are not producing yet. On the other hand, mature trees are already affected by HLB and they are declining in production and fruit quality. So the goals in both cases are different. And in the case of young trees, the goal is to keep them free from disease until they become productive and they start producing fruit, and longer if possible. In any case, the goal should always be to improve fruit yield and quality. And that's the main goal in mature trees. And we will address both cases, young and mature trees, during this presentation. Now, we are going to talk about brasinosteroids. Why this new or newer plant growth regulator? Well, many of you may remember that a few years ago, 5-6 years ago, this paper from a Cuban research group came out, and they were claiming that brasinosteroids could reduce HLB bacteria titer, especially in young citrus trees. Now, with Dr. Bashist and Dr. Vincent, we were collaborating for a couple of years, and we tried to reproduce the results from that study. And unfortunately, we were not able to see a decrease in bacteria in our trees, at least in mature trees. But we saw some other interesting effects in terms of better tree health, and we were studying mature trees. What I will show today is what we were doing later on younger trees and also mature trees, but focusing on the fruit. And that is what I will be describing during this presentation. So to give some background, brasinosteroids or brasinolides in general are a class of growth promoting steroidal hormones that control almost all aspects of growth and development in plants and help them adapting to different stresses. The nice thing for us is that one of the analogs, homobrasinolide, is available here in the US and is labeled for use in citrus right now. In other crops, this hormone has been widely studied, and it has been shown that it actually affects, as I told you, virtually all aspects of growth, and that includes root development, plant architecture, bloom time, as well as also tolerance to different stresses and diseases. For what matters to this presentation, I want just to mention that there is an increasing number of reports showing resistance to disease, although the mechanism is not clear yet and seems very complex, as brasinosteroids seem to interact with other signaling mechanisms, including salicylic acid pathway, jasmonic acid pathway, among others. And also, we will talk about this later. There are some reports of their effect in promoting maturation of fruit, especially, and this is interesting for us, especially in non-climacteric fruit. And here I'm showing an example in strawberry when treating strawberries with brasinosteroids is able to reduce the number of days to get full maturation. As you can see here, and if you apply a brasinosteroid inhibitor, you increase the number of days to get full fruit maturation. So let's move ahead and let's start talking about some results from my research. And I will start with the work that we are doing and hope to continue doing on young trees. And by this, I mean newly planted trees. Well, in our research, we have shown that this is the rate of infection in a newly planted citrus grove these days in South Florida. This is from a research study in Southwest Florida Research and Education Center. And you can see that in the conditions that we have here, in less than 6 months, you have up to 80% of the trees testing positive for HLV. And by 1 year, all your trees are infected. What we saw, and this was a surprise, was that treating with brasinosteroids newly planted trees, we were able to reduce the rate of infection. And by 6 months, only 25% of the trees were infected, as compared to the 80% of the trees that were infected in non-treated trees. In this case, we were treating the trees with 186 milliliters per 100 gallons of water, and we were applying once per month. And this picture below is 1 year after planting and treatment. And you can see clear differences in tree architecture and canopy density as compared to the controls. You can see, for instance, that the trees under the brasinosteroid treatment were not only more dense and better conformed, but also more uniform. You can see how in the water controls, they were not so uniform. So you had more differences in canopy and tree architecture. Okay, so we were, and this was really interesting, we were also able to see in these trees less incidence of psyllids per flush. And this was a significant difference. We were counting psyllids by the TAP method. This was in newly planted trees, but 1 year later, when trees started to put some fruit, we found that rust mite was also significantly reduced. And actually, we are continuing monitoring these trees that are now 4 years old, and they are still looking much better. Now, these are Valencia trees now, and at year 4, and we are having a really nice crop. And we are planning, and I will update you on that in further presentations, hopefully. We are planning to get data on fruit quality this year, so we can compare, even though we ceased the treatments 1 year ago on this, but still the trees look really much better. In any case, what we need to know is how many applications we need to get to have this kind of protection that we have seen in the last 2 slides. In other words, for how long we can get protection after a treatment. And we are working on that as we speak. This is one of the things that we are trying to do that. Try to understand for how long the protection is in the tree after we do the application. Now, let's talk a little bit about mature trees. And we did a lot of experiments trying to reproduce what the Cuban paper that I told about before, what the Cuban paper did. But we were not able to reduce bacteria titer, as I told you, probably because in older trees, the immune system is different and probably weaker. By that time, however, we started to see an increasing number of studies talking about brasinosteroids and fruit maturation, and that included citrus as well. So I started to work as a side project on fruit maturation. And we were working on mandarins and also sweet oranges. And I will show you what we did on tango mandarins. This was one of the first experiments that we did on tango mandarins. And as you know, tango mandarins are really challenging sometimes in getting full coloration. And here I show an experiment treating the fruit just once after past the mature green stage. You know that once the fruit has completed its developmental phase or phase 2 of development, it starts to break down chlorophylls in the peel and starts to build up carotenoids, and that gives the orange color. Okay, that's what we call the breaker stage, and goes from light green to yellow. But before that, you have the mature green stage, which is when the fruit is totally green and it starts to get lighter green. That's what we call a mature green. And that there is a number scale that is the AB index, and goes from negative to positive. 0 is about when the fruit is yellowing, and between 0.3 0.2 is where you have the fruit passing from mature green to lighter green. When we applied at that time, we were able to see an increase in coloration in the fruit attached to the tree, just after one application. And in this case, we were using 10 times less concentration than I told you before. So we were using 18.6 milliliters per 100 gallons of water, and we were applying that to the tree. And again, timing of application was really important. And you will see that in a picture here. So on your left, at mature green stage, that is below this 0.3 to 0.2 that I told you. So it's about minus 0.4. That is the mature green stage. You can see that here, application of brasinosteroids, yes, you get some color development, but not much. And it does not get better than that. But on your right, if you have passed that mature green stage, minus 0.25, as I showed previously, you get much better color. You can see here, this fruit over here, and you get into positive values. So that means that the fruit is getting really orange. For comparison, I'm just showing here the water control. And a control treatment that we did with brasinosteroids, and as Dr. Bashid said just before, we know that it arrests color development, and ABA control also because at that stage we know that it induces coloration, but you can see that brasinosteroid treatment was very superior here in terms of improving coloration. Well, this was really promising, and we have been doing this for a couple of years. And the fact is that the effect of brasinosteroids on citrus maturation is being increasingly studied. And this paper that I showed here just came out last year, and is from some of my Spanish collaborators, and they are working on blood oranges. It's a totally different cultivar, and they actually produce mostly anthocyanins and no carotenoids, but still they have seen that even during post-harvest, brasinosteroids have an effect on some maturation traits. And I will show something about that in a while. But I wanted just to introduce this to resume in a couple of slides. But what I want to show you now is that in our own research, we have seen that internal quality is improved after just one application of brasinosteroids. We have done this in Valencia only at this time. And these are working graphs that I'm sharing with my student as we discuss results. So you can see that comments are attached because these are, as I tell you, working graphs that we are working right now, and you are seeing them before we submit this for publication. So you are seeing this for the first time, and you can see that when we apply just before bloom, we are able to stop carbohydrate depletion or decline or shortage that occurs in the fruit, probably due to the competence for resources from the new bloom. See, the date that we applied was that we did the application was February 2nd. Excuse me. By the mid-February, these trees were blooming and setting fruit here in the Southwest. So probably this decline in sugars was related to the competence for resources. Now, if we apply again after fruit set, we see an even increase in Brix as compared to the controls. And please compare 9.5 versus 8.7. And this was just one application after fruit set. So in this case, we did two applications, one before blooming and another one after fruit set. And the same thing was true for the ratio here in your right. With the first application, we got a nice increase in ratio. It went from 7.5 to 9.5 roughly, and this was lost as the fruit started to naturally build the sugar content. But the nice thing is that there is a moment in which we can actually advance internal maturation in terms of sugar build. And we believe that this is promising. And now let me show you again some of the results of the paper from my colleagues in Spain that I told you just before. And you can actually see how they have something really similar. And I just marked this in this green box. And this is interesting because this is post-harvest storage. And you can see the controls is the red bars. And the sugars, they are looking into sucrose, glucose, and fructose. So the sugars in general, they are depleted. The fruit is during post-harvest, but still metabolically active. So and there's no sugars coming from the tree because the fruit is detached. So the sugars are depleted, as you can see, but any treatment, any concentration of brasinosteroids, and they try 3 different concentrations, are able to maintain sugar levels. Okay, and that's basically what we got in our experiment. And if you see the dates, is even more interesting because see they treat here at harvest and they look into 42 days, but for instance by 1 month they have the same levels. And if you look at our results, we treat February 2nd, and we maintain the sugar levels at least until March 3. That's again 1 month, so it's very consistent with what they get. So we believe this is really interesting and promising, and if you see, we did the second application here, and it looks like that there is a moment in which we can even advance maturation. We are still working on this. And in summary, what this shows is that applying brassinosteroids every other week, we can advance maturation in Valencia fruit. And this is another working graph that I will walk you through this, because we believe this is really promising. We have done this again also for a couple of years now, and with 2 different concentrations, the 2 concentrations that I told you before, 18.6 milliliters and 186 milliliters per 100 gallons, and we didn't see much difference between these 2 concentrations. We were working on the lower and the higher range values here. So this is a complex graph, but what you can see here in the solid black line and in the dashed blue line is how was internal ratio. This is Brix to acid ratio. This is how was internal ratio in the years before HLB with healthy Valencia trees. Okay, and in those years, we are talking about 2005, 2006 season, we got the ratio of 9 around early February. You can see it here. Okay, the ratio of 9 was around early February. Now, the black asterisks that are inside the green boxes, they are, you can see they are below the line. These black asterisks show the ratio that we are getting now these days here in Southwest Florida Research and Education Center in our experimental plots. And you see, if you draw a line, you see that this line would be parallel to what we had before, but lower. And this is our problem. So by early February, what we are having is around 7 in ratio. Okay, and we need to get into April, well into April, to have a 9. If we are lucky enough to have still some fruit on the tree by then, because we are having increased fruit drop. But look what happened with brassinosteroids. Okay, and you can see here the red and green asterisks there. So we are getting an increase in ratio, and in February we are getting almost 1 month advance in maturation. So in February we are already at 10 actually. Okay, and that fruit is commercially acceptable because of that. And we have also 2 advantages. We are getting the fruit ready for processing earlier, and we are avoiding fruit drop as we are harvesting sooner. We are having this ratio of 10 by early February, so the tree has not bloomed again yet in the year because we are early February. So we are avoiding that problem that we are getting if we go into March or April. So this is what we need to refine now in terms of timing, when to apply, because we don't know if we apply, for instance, in November or December for Valencia, what we will get, because we we applied in February, so we don't know yet. And we don't know how many applications. Okay, this was done every other week, but as I told you, one application was able to induce a jump in BRICS, at least for a while. So this is what we are planning to do next, and as we believe this has a lot of potential. And also talking about potential, we need to see how this works on other varieties like Hamlin, because advancing maturation on Hamlin may also have a huge effect on avoiding fruit drop in this variety if we can advance maturation and be able to harvest earlier, but we haven't tried in Hamlin yet. So this is basically what I wanted to share today. So you can see this is still a lot in the making, but we believe this has a lot of potential. So our take-home messages are, first, that brasinosteroids can actually reduce rate of HLV infection in young trees. We know that when they are planted healthy, and the mechanism by which is doing that is not clear yet. We are researching on that now. We still don't know for how long the protective effect of brasinosteroid lasts after application in young trees. And we are also investigating this. So what we are doing is we apply, and then we monitor these trees until we get we have some marker genes that we can actually assess to see when that expression goes down, and see if that correlates with an increase in infection. So that will tell us for how long the protective brasinosteroid effect lasts in the tree. Now we know already that brasinosteroids work well in a range from 18.6 to 186 milliliters per gallon of water. Probably the effects are a little bit different, and we are working on that. And we typically use 1 gallon of water to full cover one mature tree. And finally, we have seen that brasinosteroids can advance internal fruit maturation, at least in Valencia. And what we need to refine is time of application to maximize this effect. And this is still under research. And with this, I will finish my presentation, and thanks for your attention. Thank you.